So we're going to be doing equations of circles related to what we were just doing, a bunch of stuff with circles, but we're going to be dealing with them on graphs today. So up at the top on your notes page, I put a little thing that says, remember, distance equals the square root of x1 minus x2 squared.
Oh my God.
Good. Plus y1 minus y2 squared. All right, let's walk through this first one together. If we are using our distance formula, it might help to label these points as x's and y's. So this 1 in the very front, is that an x or a y? It's an x, so I'll call that x1, which makes the 5 y1. The 4 is my x2. The other one is my y2. So the distance between those points is the square root of, if you want to do 1 minus 4 you can, or you can do 4 minus 1, but you just have to be consistent. So the way I have it set up, I would write 1 minus 4 squared plus, because I started with 1 in my first set of parentheses, I have to start from that same point. So I have to start with the 5 minus my other y is a 1 quantity squared. If I take 1 minus 4, what do I get? -3. And when I square a -3, what do I get? Positive or -9?
Positive.
Positive. A negative times a negative is a positive. And then in the back, I have to take 5 minus 1. 4. 4 squared is 16. When I add 9 and 16, what do I get? 25. The square root of 25 is 5. So that's my distance for number 1. Let's try the second one. Distance equals square root of, give me an x value. On number 2, 0 minus my other x value, also 0 squared, plus, now because both of our x's are the same, it doesn't really matter, so give me a y value. Okay, 8 minus my other y value, 4, that gets squared. Now if I take 0 minus 0, I get 0, and I square it, I still have 0. So if you want to write it, you can, but you don't really need to, because it's not going to change anything in the back. 8 minus 4, 4 squared. The square root of 16 is 4. All right, number 3. Distance equals square root. Give me an x. 3 minus, give me the other x. 9 squared. Plus, now this time when you give me a y value, you have to give me a certain one. Which one does it have to be? It has to be the 1. If we started with the 3 in our first parentheses, we have to start with the coordinate that's matched up with the 3, which would be a 1. So those both have to go in the fronts. Minus my other y, 9. Now, if in your first parentheses you had 9 minus 3, then in your back parentheses you better have 9 minus 1. One of these is flipped, they both have to be flipped. Equals 3 minus 9. -6. -6 squared is 36. Plus 1 minus 9. -8 squared is 64. When we add those, we get 100, and the square root of 100 is 10. So that's my distance for number 3. Do we have questions before we move on to number 4? What's different about the numbers in number 4? We have some negatives, so we've got to be careful with our signs. So let me make this easier to show up on the board. All right, number 4, distance equals square root of, give me an x, -2 minus the other x, squared, plus, give me the y that I need, 5, minus the other y, careful, -4. So we're subtracting a -4. That really means we are adding it. So when there are negatives, we've got to be careful with the signs. -2 minus 10. -12. Good. Be careful with your signs. -2 minus 10 is -12. Square it. 144. Plus 4 plus 5 is 9 squared. 81. When we add those together, what do we get? 225. The square root of 225 is 15. All right, so today you can see our objective is to graph and write equations of circles. All right, so these notes, you should have this diagram here for you that we are going to be drawing on. So it talks about having a right triangle. So what that means is I am going to, from the center of this circle here, I'm going to draw a hypotenuse that touches the circle. Ideally, it would be a straight line. That's better. And then I'm going to use that to draw in the rest of the right triangle. So this is what would be called R over here, the length of the hypotenuse. And then if I take this and extend it out here and drop in this line straight down to form a right triangle whose hypotenuse is a radius of the circle, then this length that runs down at the bottom, that's on my x-axis, so that's why over here they say x, is the length of one leg. And this other leg over here they called y, which you can see it runs parallel to our y-axis. So that's why they labeled those x, comma, y. Got a right triangle here. So by the Pythagorean theorem, if we were to use this r, x, and y that they've told us to from this right triangle that we drew in the circle, what could we write? Instead of a squared plus b squared equals c squared.
X squared plus y squared is all squared.
Beautiful. X squared plus y squared equals r squared. You can use a capital R or a lowercase r. Doesn't make a huge difference. This is an equation of a circle with a center at the origin. So you just wrote the equation of a circle. Good job. That's what, in general, our equations are going to look like today. Now, our center is not always going to be at the origin, so we're going to have to talk about when the center of it moves. So here's our standard equation of a circle. You'll see it looks just a little bit different. In a coordinate plane, the standard equation of a circle with a center at h, comma, k, h and k just represent numbers, and radius r. The equation for that circle is x minus h in parentheses squared plus y minus k squared is equal to r squared. So this h and k that they've introduced, that's what shifts the center around from being at the origin. If the center is at the origin and those are both zeros, then this goes back to just being x squared plus y squared equals r squared. We are going to practice using this. The examples start on the back of your notes sheet. I put the diagrams in there for you. We are to write an equation of the circle using the graphs that they gave us. So we're just going to do one of these at a time. What do we know about the center of these? Where would you say the center of the circle is on all of these? The origin. That makes it easier for us if your origin is at 0, 0. So on these, I would recommend just saying where your center is first, even if it's not at the origin, if it's not at 0, 0. Identify your center first and then identify your radius. And once we have that information, it'll be easier to write the equation. So now that we know the center's at 0, 0, if you want to color that in, make that point a little more bold, we need to figure out the radius. How are we going to figure that out? Where does the radius go? It touches 2 points. One of them has to be the center, and the other one has to be somewhere on the edge of the circle. So, I could take a point from the center and give it to the edge of the circle, but do I know what this point right here is? No. So that's going to be hard for me to figure out how long that segment is. But where could I draw a segment that would make it really easy for me to figure out how long it is? Along the x-axis or along the y-axis. If I go straight out to the side, I can quickly count that my radius is how long? 3. R is equal to 3. If you wanted to go up along the y-axis instead, that's fine. Down, even though it's -3, it still has a length of 3, a distance of 3, or to the left. Somehow we want to go along an axis to be able to count our radius. We don't want to go at an angle. Does that make sense? Okay. Now that we know all of this, we can write an equation. Now, in general, our equations are x minus h squared plus y minus k squared equals r squared. I'll show you on this first one what I was talking about on the last slide about our origin being at 0, 0. The center is h comma k. So if instead of an h I put a 0, and instead of a k I put another 0, what am I plugging in for r? 3. Notice that r gets squared, so I'm going to put 3 squared. If I take x minus 0, what do I have? Just an x. X minus nothing leaves me with x. It's getting squared. Plus, if I take y minus 0, I'm left with y. It's also getting squared. Equals 3 squared is 9. So that is the equation of my line. Or not my line, my circle.
That's the answer.
That is the answer. So if your center is at the origin, you do not necessarily need to show the x minus 0, y minus 0 step. But that's the only time you wouldn't show that. Any other time, if you have other numbers there, they've got to stay there. All right, on number 2, where's my center? The origin, 0, 0. So I already know that my equation is going to be x squared plus y squared equals some number squared. That number that I need there for the end is my radius. What's the radius this time? 2. Good. Again, I like to go straight out to the side to count my radius, but you could go up, down, or to the left. My radius is 2, so I need to take 2 and square it. When I square 2, I get 4. So my answer is x squared plus y squared equals 4. That's the equation of the circle. Number 3, again, my center is 0, 0 again. I'll write this up at the top. My center is 0, 0. Did anybody find the radius? I would agree that it's 4. So we start at our center and count straight out to the side. That would be 4 units. So r equals 4. So we go to write our equation. Because our center is at 0, 0, we know it'll be x squared plus y squared equals 4 squared. And 4 squared is 16. Questions about how we wrote that equation? All right, on these next few examples, Mariah wants to try on these next two. So I'm real quick, I'm just going to put the general equation back up at the top. So on these, all we're really doing is plugging in what they tell us and then simplifying what we can. All right, on number 4, we've got our center. It might help if you label your center as H, K. So that way we just have to plug everything in. They already told us what the R was at the end. So I need H, K, and R to write my equation of a circle. We have X minus, what's my H? 2. That whole thing gets squared. Plus y minus, what's my k? Negative 1. So minus a negative means I'm changing this to be plus 1 or adding 1. Squared is equal to, what's my radius? 3. And that's also getting squared. Now, what I think is the nice part about this is there's nothing for us to simplify with the x minus 2 squared or the y plus 1 squared. All of that's going to stay exactly the same. The only thing we need to simplify is the radius squared. What is that? 9. So x minus 2 squared plus y plus 1 squared equals 9. And that is my answer on number 4. That's it. Plug stuff in and simplify. The hardest part about these is making sure you remember that the formula involves negative signs. So if your center has a negative number, like it did on number 4, it ends up changing it to a plus sign. The signs are kind of backwards from what you think they would be if you just look at the center. That's the only real tricky part about this.
Can we skip like the equation part?
You want to go straight to your answer? Sure. No.
Like step by step.
Okay.
No.
All right.
All right. So parentheses.
Mm-hmm.
X plus 2 squared
I'm going to change it to a minus.
minus 2.
Because remember, we just said the signs are different from what we think they should be. That's the tricky part. Okay, good.
Okay. Plus y minus 3
Mm-hmm.
squared
Good.
equals 4.
Beautiful. So Mariah went ahead and squared our radius already and just put it straight in. I'm fine with you doing that. Again, remember to watch your signs when you put your center in. All right, what is it?
minus 0. Hold on. Square
Mm-hmm.
plus y minus 1 square and 3 square.
Good. So that's going to be our first step. Now this one is a little tricky because there are two things that we can simplify.
The zeros?
Yep, the part with the 0 can be simplified. So Keon, what does that become?
Square.
X squared. Yep, just an x squared.
Then y minus 1 square
Yep, that part stays the same.
and equals 9.
Beautiful.
I like this. This is new.
All right, we are now going to switch gears, and instead of writing the equation, we are given the equation, and we have to come up with the graph. So we need to be able to identify our center and our radius first, and then we'll worry about plotting all of that. So I need my center for number 7. Jaden,
Negative 2.
careful with your signs.
Oh, would it be 2?
2, comma,
Comma, negative
careful.
3.
3.
3. It's just going to be 2, comma 3. So the signs are opposite of what you see written right there. So our center is at 2, 3, both positive. Julian? Yes, the radius is 4 because you have to square root this number in the back. And lucky for us, they gave us perfect square numbers. So it's a nice even number when we square root it. We have questions about finding our center or our radius. Now we just have to use that to graph it. So the first thing I need to graph is my center. Where does it go? 2,
Go right to.
right 2,
3.
up 3. Now this one, our graph is not going to be quite big enough, but we'll just have to deal with it. So then we have to use our radius.
Do we have to draw the circle?
Yes.
Oh, that's,
Now, your graphs on these are not going to be quite as accommodating as we would like to be able to fit this, but we're just going to do our best. We're just going to do our best. So we'll definitely be able to get some of our points. This is our center. So if you want to put a little C by it so that you know that's your center, your circle, so the line you draw around, will not touch that point. Does that make sense? That's just for us to use to be able to count out our radius. So the easy directions for us to count out our radius are going to be to the left. So from the center, I'm going to go left 4 and put a point. 1, 2, 3, 4. I can go down 4. 1, 2, 3, 4 and put a point. And I can go right 4. 2, 3, 4 and put a point. The only one that doesn't fit very well on this particular grid, because it's just a little small, is the one that goes up. 1, 2, 3, 4. We just kind of have to estimate that a little bit. Now, do not draw me a square or a diamond. I understand we've only got these 4 points. I understand that our circles may not be perfect, but I need this to be rounded. It should not have sharp edges. Does that make sense?
yes.
We should be making curved lines that go through these points. Notice mine's not perfect, and that's fine. I want you to do your best. If your circle touches your center, you're not getting any points. The circle should never touch the center. Okay? All right, we'll do our best with number 8. It's not going to fit very well on the grid that's provided, but that's okay. Let's first identify our center. What is it?
It's 6.
Good.
Oh, 0, 5.
Good. So 0, 5 is our center. Notice that we had to know that 0 was our x-coordinate because there was not a number with the x. If it's nothing, it's a 0. Let's talk about that radius. What is it?
6.
6. We have to square root 36. We get 6. So let's plot our center. Where's it going to be? Up 5. That's our center. So remember, our line for our circle won't go through that. In most directions, it's not too bad to fit this on the graph. I can go down 6 pretty easily. And I can go left and right 6 pretty easily. The only one that does not really fit on the graph is the one that goes up straight from our center. So if we just extend this line straight up, so there's 1, 2, 3, 4, 5, 6. Again, if I'm looking for something closer to perfection, your circle will be able to fit on there. But when you do this, do not give me sharp corners. Make sure that it is rounded.
Oh, I definitely short.
It should not look like a diamond or a square. It should be round. All right, we've got one more we need to graph. Where is this center going to be?
-4, -6.
Very good. Remember, the signs switch from what's there. So our center's at -4, -6, with a radius of 5. We square root 25 to get 5. Now this one again, not going to be super pretty on this graph. Where is -4, -6?
Over 4.
Left 4.
Left 4.
Yep.
Down.
Down 6. So that's where my center technically should be. So I'm going to pull up a different graph so that I can show you the whole graph. You would only really be able to fit 2 of your points on here, and the other 2 would be way below. So let's just switch our view to some graph paper. Ooh, not what I wanted to do. There it is. So our center was at -4, -6 with a radius of 5. So we'll just create a grid here and see if we can fit it on there. All right, to get to -4, -6, we already talked about going left 4, down 6. There we go. This should be big enough for me to put all of it on. Then to get my other points, where am I going from my center?
5.
Out 5 units in all directions. We have to go out 5 units from our center in all directions. So I'm going to go to the right 5 units. I'm going to go up 5 units. To the left 5 units. And down 5 units. So this is a relatively large circle from the ones that we've been doing. Again, does not have to be perfect, should be round. Should not touch the center.